Eruption is giving us a spectacular sight. However, it is creating some dangerous conditions.
At 3:27 in the afternoon on May 14, 2026, a vent inside the summit caldera of Kilauea volcano began throwing lava into the air. If you had been standing at one of the overlooks on the rim, you would have heard it before you saw it. A low roar climbing out of the earth like something waking up, something that had done this 46 times before and was about to do it again. The fountains at that point were modest, almost casual by Kilauea's recent standards. Thin jets of molten rock lofting upward from the north vent in what scientists would later describe as precursory activity, not yet the main event. For 29 minutes, those fountains built and pulsed and climbed, and the U.S. Geological Survey didn't even count them as the start of the episode. Not yet. Because what was coming would make those early fountains look like a warm-up act for something far, far larger.
Eruption is giving us a spectacular sight. However, it is creating some dangerous conditions.
We've had unprecedented amounts of tephra, which are large chunks of volcanic rock and volcanic ash.
This was episode 47. And to understand why that number matters, you have to understand what Kilauea has been doing since December 23rd of 2024, because it is unlike anything this volcano has done in recorded history. Most eruptions at Kilauea follow a pattern the world has come to expect. Lava breaks the surface, flows for days or weeks or sometimes months, and eventually the system exhausts itself and goes quiet. That's how it worked in 2018. That's roughly how it worked through decades of prior activity. But starting 17 months ago, Kilauea abandoned that playbook entirely and began operating in cycles. Short, intense bursts of eruption separated by periods of pressurization and quiet. Each cycle ending in the same way, with hours-long episodes of sustained tall lava fountaining that rank among the most spectacular volcanic displays anywhere in Hawaii since 1969. 47 of these episodes have now occurred in a row, and that number, 47 discrete eruptive episodes from a single volcano in under a year and a half, has no parallel in Kilauea's historical record. None. The activity has been confined entirely within the summit caldera, fed by as many as 4 separate vents, well away from any structures. And in the professional assessment of volcanologists monitoring the eruption, lava flows do not currently threaten communities. That should be reassuring. And it is. For now. Because what happened during episode 47 is a reminder that even a well-monitored, well-understood volcano can still produce moments that stop you cold. After those initial 29 minutes of precursory fountaining, the character of the eruption changed at 3:27 p.m. local time, and the USGS marked that as the true onset. The rate of lava effusion shifted. The fountain stopped flickering and began to climb with purpose. Within 35 minutes, lava from the north vent was reaching 200 feet into the air. A column of incandescent rock nearly as tall as a 20-story building, glowing orange against the afternoon sky. 15 minutes after that, the fountains hit 300 feet, and the overlooks around the caldera rim were filled with people who could feel the heat on their faces from hundreds of yards away. And then, in just another 25 minutes, the fountain surged to 500 feet, and that is when the air itself began to rotate. Multiple spinning columns of superheated gas and ash formed near the base of the fountain, pulling fragments of still molten lava into tight vortices that moved across the southwest portion of the caldera floor. They looked like tornadoes. They were not tornadoes, not technically. They were rotational features more akin to dust devils, driven not by supercell thunderstorms, but by the sheer thermal violence of freshly erupted lava heating the air above it so rapidly that the atmosphere had no choice but to spin. Scientists called them lava whirlwinds. The people filming them from the overlooks called them something else entirely. The vortices didn't last long, but they carried glowing lava fragments with them as they moved, and the images they produced are among the most striking ever captured at an active Hawaiian eruption.
It looks like it's actually getting bigger. It's getting brighter for sure. Yeah. That lake now. Holy Lord.
And still the fountains kept climbing. By approximately 5:20 p.m., just under 2 hours after the official onset, the north vent reached sustained lava fountain heights of 200 meters. That is 656 feet of continuous molten rock being hurled vertically into the atmosphere, taller than the Washington Monument, taller than most skyscrapers in Honolulu. A column of lava so massive that it generated an eruption plume, reaching up to 20,000 feet above the vent, high enough to interact with commercial aviation corridors, high enough to be tracked on satellite, and yet, remarkably, only minimal tephra fragments, the solid pieces of volcanic debris carried aloft by the plume, fell back onto the overlook areas where spectators had gathered to watch. The wind cooperated. The geometry of the caldera helped. And because of that, unlike a handful of earlier episodes that forced evacuations of viewing areas, episode 47 allowed people to stay and witness the full escalation from beginning to end. The eruption held near its peak for a stretch, and then, following a pattern that volcanologists have now observed dozens of times, the system began to wind down. Lava fountain heights decreased. The rate of effusion slowed. The roar that had filled the caldera for hours gradually faded to something quieter. And by 1:27 a.m. on May 15th, roughly 9 hours after the episode's true onset, Kilauea went silent. The fountain stopped. The lava stopped flowing, and the 47th eruptive episode of this extraordinary sequence was over. In total, 5.2 million cubic meters of lava were erupted during those 9 hours. To put that in terms your brain can actually hold, that is enough molten rock to fill more than 2,000 Olympic swimming pools. And it all came out of a single vent inside a caldera at the top of a mountain in the middle of the Pacific Ocean. And here's the part that should make you sit with that number a little longer. By the standards of this eruption sequence, episode 47 was below average in intensity. It was, in volcanological terms, a quiet one. The explanation likely lies in timing. The gap between episode 46 and episode 47 was unusually short, part of a trend that has been accelerating since episode 43, and a shorter recharge period means less pressure, less accumulated magma, and a comparatively smaller release when the system finally lets go. But that word, comparatively, is doing a lot of heavy lifting, because 656-foot lava fountains and rotating columns of airborne magma do not feel small to anyone standing close enough to see them. There is something else worth noting about the recent pattern, something subtle but potentially significant. For most of this eruption sequence, activity has involved both of the caldera's primary vents, the north vent and the south vent, with both typically producing lava fountains during eruptive episodes. But since episode 43, only the north vent has generated fountaining. The south vent hasn't been entirely quiet. In the days leading up to episode 47, it overflowed 75 separate times, producing small lava flows on the caldera floor. 75 times. And yet when the fountaining phase arrived, it was the north vent, and only the north vent, that erupted. The implication is that something has shifted in the underground plumbing geometry connecting these vents to Kilauea's magma supply, a reconfiguration that is routing the explosive energy preferentially through one conduit while the other bleeds off pressure passively. What caused that shift, and whether it will reverse, is something scientists are still working to understand. And that brings us to the question that has followed every single one of these 47 episodes since December of 2024. The question that gets asked before the lava has even finished cooling. When does the next one happen? The honest answer is that it is too early to say with certainty. The cyclical pattern has been remarkably consistent, but volcanic systems are not clocks. And the accelerating trend in recharge times since episode 43 makes the calculation harder, not easier. Based on the data available, a reasonable window for episode 48 falls somewhere between May 24th and June 17th of 2026. That is a range of more than 3 weeks, which tells you just how much uncertainty still lives in the system. But if the trend holds, if the gap between episodes continues to shorten, the next one could arrive sooner rather than later. Right now, tonight, Kilauea's summit caldera is quiet. The lava lake that feeds these eruptions is slowly refilling. Tilt meters on the volcano's flanks are measuring the ground as it swells, millimeter by millimeter, under the pressure of fresh magma rising from below. The south vent is likely already producing small overflows again. 1 here, then 5, then 12, the count building in the background like a pulse that only the instruments can hear. And somewhere between 4 and 33 days from now, if the pattern that has held for 17 months continues to hold, the pressure will reach a threshold, and the north vent will open again, and lava will once more climb hundreds of feet into the Hawaiian sky. That number 47 is not the final count, not even close. That's it for today, folks. See you in the next video.